Hello, Assalamualaikum and good morning everyone. So today we will present our experiment project. Our title is Experimental Verification of the Biot-Savart Law, Magnet Field Strength as a Function of Distance from a Current Carrying Coil. This is my group mate. So first, our introduction is magnetic field are produced whenever an electric current flow through a conductor. The relationship between electric current and the magnetic field generated is described by the Biot-Savart law. This law states that the magnetic field strength depends on the magnitude of the current and the distance from the current carrying conductor. The project goal is to verify the Biot-Savart law experimental using a current carrying coil to investigate the effect of distance of magnetic field strength and to measure the magnetic field produced by a current carrying coil using smartphone. That's all, thank you.
Now let us look at the core physics of our project. The Biot-Savart law describes how a current carrying wire makes a magnetic field. This law states that magnetic field get weaker as you move further away from the wire. We can see this relationship clearly in our formula. B is inversely proportional to R. Here, B stands for the magnetic field strength, the letter R represents the distance from the wire. This formula proves that magnetic field drop as you move away from the source. For wireless EV charging, this is explained why keeping a small gap between the pad is critical to avoid power loss. Next, let us go over our lab setup and methodology. For our apparatus, we use 5 main items. We use a 9-volt battery for power and a hand-wound copper wire coil. We also use a smartphone with the 5-Force app to measure the magnetic field. Finally, we use a ruler to check the distance. Our procedure follows 4 simple steps. First, we want 30 to 50 turns of copper wire to make a coil. Second, we connect this coil to the 9-volt battery. Third, we measure the magnetic field at distance from 1 to 5 cm. Lastly, we record all the data reading for our final analysis.
Moving on to our experiment results. As shown in the table on the slide, the B wire values were calculated by subtracting the B switch off readings from B switch on to account for and neutralize the ambient background Earth's magnetic field. Based on the plotted graph, you can observe a clear downward trend in the magnetic field strength as the sensor moves further away from the coil. The value drops from 22.43 units at a distance of 2 cm down to 14.14 units at 4 cm. The initial decay pattern closely aligned with the Biot-Savart law, which establishes that magnetic field strength is inversely proportional to distance. However, as the distance reaches 6 cm and beyond, we notice an anomaly where the B wire value drops abruptly close to zero and subsequently crosses into negative values. Theoretically, the net magnetic field should not be negative in this experiment setup. Upon analysis, the systematic error occurred because the baseline background readings, which is B switch off, did not remain stable throughout the later stages of data collection. A slight shift in the sensor orientation or the presence of nearby ferromagnetic materials in the lab likely caused the background baseline to spike higher than the actual switch-on readings, resulting in a negative net value after subtraction. Despite the environmental interference encountered at greater distances, the primary objective of our experiment to verify the Biot-Savart law is to successfully demonstrated through the clear inverse trend observed in the early phase of the graph.
So there's come to my part. So this video shows the experimental setup used to investigate the relationship between magnetic field strength and distance. So a copper coil was connected to a DC power supply to generate a magnetic field, while a smartphone magnetometer application was used to measure the magnetic field at different distance from the coil. So, based on the graph obtained, the magnetic field strength generally decreases as the distance from the coil increase. So this trend agrees with the Biot-Savart law, which states that the magnetic field is inversely proportional to the distance from the current carrying conductor. So, however, several limitations may have affected the accuracy of the result. So, these include the limitation accuracy of the smartphone magnetometer, the influence of the Earth's magnetic field, and fluctuation in the power supply during the experiment. So, in conclusion, the relationship between magnetic field strength and distance was successfully observed. So, despite some experimental limitation, the result generally support the Biot-Savart law. That's all from us. Thank you.